Greetings everyone, welcome back. So in this video we're going to talk about a concept called functions. We'll do it over a sequence of videos, but we're going to introduce the concept in this one. Okay. So what is a function? And the easiest way to describe this is to think of it as a black box. And what I mean by that is we have some information that we're going to pass into a block of code. Okay, some information that we pass into a block of code. The code's going to do something, right? And it's going to send some information out, okay? Now, a key aspect of it, when we talk about something being a black box, what we mean by it is that we do not need to know what's going on in here, okay? We don't need to know what's going on inside of the box, effectively allowing us to hide implementation details, okay? Hide information details. So you might have some code that can have a lot of complicated logic or can be hard to read and interpret, but it's still effectively easy to use because all you have to do is pass some information in, okay, and then read the information out, and you don't need to understand what's going on in here, okay? So we'll learn how to build these things, and this gets to a concept of code reusability, right? You build some logic once, and you can reuse it multiple times. We'll see that as we go forward. So let's look at an example of a function, and we've already used these, right? We're going to learn how to build them, right? But first, let's take a look at something that we may have already used, okay? And so here we have something called the square root function, okay? And let's look at what is defined as a function prototype. This name prototype here, okay, sometimes you do see it written other ways, okay? Sometimes you refer to it as a header, okay? And sometimes you also see it, oh, there's my dog Gus. Sometimes you often hear it as called a signature, okay? I think I will stick, because it's a little bit easier to connect with some other concept that we'll see later on. I will most likely use the term header here. But if you see it written as prototype or written that way, we're really referring to the same thing. Well, what do I mean by it? What is it? Okay. Well, effectively, right, a function prototype is defining the inputs and outputs. Okay, defining the inputs and outputs. It's also defining the name of the function. What do we want to call it, right? You want to just give it any sort of meaningful name, a name that is clear of what it does, right? So we look at the square root function, right? We have some input coming in, right? We take the square root of that input, and when we have the output coming out, right? It's important that for the inputs and outputs that we define what the data types are. Okay, we need to define the data types for what data type is coming in and what data type is coming out. Okay, so if we were using this function, we would do something like this down below, where we look here, right? We could pass in whatever we wanted as our input, right? And then the result of that square root, so in this case it would be 2, would get stored in variable out. Okay, that's how we would call the function. Okay, so a big part of functions is, like I was saying, is in terms of code reusability, is we can pass in all sorts of different inputs. Okay, it's not like quote unquote hard coded to only work with one value, right? It's going to work with whatever value that we pass in that's a valid input. Okay, so whether we're passing in 9 or 4 or 54, or basically it works for whatever variable that is a valid input. In this case, we'll call that x, is going to take the square root of that. Okay, it makes sense, right? That's effectively what a square root does. Okay, now remember that somebody using this, right, somebody taking the square root of something does not need to know, right, what the code logic is doing that actually did that calculation. Okay, so a user of that function doesn't need to know what the code logic was that performed the operation. Okay, they just need to know how to call it and effectively what it means, right? What are they trying to do? What are they accomplishing by using it? Okay, the details can be all hidden. right? We do not need to know the details here, aka it's a black box. It's a black box. Okay, now we've used the square root function before because it's defined in the math library. Okay, it's defined in the math library. If we went into our code and we did something like this at the top of our program, and we said, hey, we want to include math.h, right? We're including this math library. And effectively what a library is a whole bunch of functions that are all, connected in some way, right? They're not like random functions for all different things. They have some sort of shared mission. And in this case, the math library is all sorts of commonly used math functions, right? You got your square root function, you got your power function, maybe an absolute value function, and others commonly used ones that we kind of put all these functions together, or somebody wrote them, they built a library, okay? And we could reuse code that other people wrote by being able to send in input into that library, okay? By sending in some input into that library, okay? It's calling this, in this case, the square root function, and then we're going to get an output out from it, okay? And we do not need to know how the library was built, okay? And see, this is like, in a sense, what we're doing is we're not reinventing the wheel, okay? As you're building more and more complicated programs, you want to rely, right? Effectively, you're trying to build something that is custom, but you're going to rely on things that other people have written in these common libraries so that you don't have to reinvent the wheel every time you're trying to do something. And we've already used a bunch of functions. Printf is a function. Scanf is a function. Right? These are things that are built by other people that we're leveraging, and they're standard, right? They're part of the standard IO library, the standard library. Okay, so let's build a function now, right? We're going to often build our own, okay? Build our own, and we can even build our own libraries, which we will do at some point. And let's look let's imagine, let me actually just back up 1 second here, and let's just think about an example of something that we might want to build. Let's imagine we want to build a function that calculates a letter grade based on a numeric grade. So what I mean by that is we can have something coming in as an input that is a numeric grade, say 0 to 100, okay? And let's imagine somebody, had, I don't know, we'll say 83, okay? And it goes into our function that we're going to call, we're just going to give a name. Okay, we're going to call it get letter grade. Okay, and that's going to return a letter. Okay, now we're going to keep it simple. Let's not worry about pluses and minuses and stuff, just so it keeps the code smaller. Okay, so we're going to build a function that the inputs come in, and then so like maybe if somebody had 75 coming in, right? It's going to have C, right? So it'll work across a whole wide range of different inputs. So effectively, we're going to have one input coming in, and we're going to have one output coming out, okay? Let's look at the data types of this. First step, right, is to define the function header. And what I mean by that is we need to know three things, right? We need to give it a meaningful name, which I already did. Okay, it's the name. Okay, you just pick a name that's descriptive, right? We need to know what the inputs are and the data type of the inputs. Okay, I'm going to say that the input here, it depends on what we want to allow, like 83.5 or just integers, right? Whatever way we do it, like maybe we'll just say in this case, we'll just assume it's integers. You can imagine this being a double as well. So maybe the input is an integer, okay? And the output, like I said, we're not going to worry about pluses and minuses. We're going to say the output is a character, a char, okay? That's the information that we need. Based on that, okay, we can define some key thing about our function, okay? And we could say that our function is going to look like this. The output is going to be the output is going to be of type char. Okay, the name that I just made up, right? So anything meaningful, get, letter, grade. You might have think something else might be better, but you know, it's whatever you decide, as long as it's descriptive. And we're going to pass in a numeric grade. Okay. This is going to be our function, and this is going to be the code block for the function. Okay, the code block for the function. Now, I also have discretion over what I want to call the input. Again, just give it something that's a meaningful name. Okay. All right, so this is our function, and we're defining it in terms of, right now, this is what the black box is defined, right? Just like what we were writing before, right? What's coming in, the name of the function, what's coming out, right? However, in here, in this code block, if we're building our own function, we're responsible now for writing the logic, right? So we need to write the logic to support this. And so this is going to be the implementation details, right? The implementation details go here. Notice these implementation details, they're all encapsulated, right? They're kind of hidden within this function code block, right? In this function, effectively in this function scope, okay? All right, we look at the a way of building this, right? If we look at this, here's our function, here are the details, okay? And I mean, there's multiple ways we could build this, but effectively we're going to assume that the grade's an E, and then we're going to see if it's something else. So if it's greater than 90, it's an A. Greater than or equal to 90, it's an A. If it's greater than or equal to 80, then it would be a B, and so on, all with else if, so it's only going to fall into one of those. And then a key thing to indicate is to show here is we have this reserved word called return. Okay, right? We have this reserved word. Okay, reserved word, right? We can see from the syntax highlighting, right, that it's blue there, and it indicates something built into the language, right? Okay, so we have this reserved word here, right? And what the return does is it takes this value, this value, and it sends that, right, as the output. Okay, as the output. So in this case, that's a char, right? A char. It has the data type needs to match, right? The data type of this letter here, okay, must match the output data type here that's previously defined. Okay. Now below we see our main, which is also a function, right? In the main, this is the entry point, right? This is the entry point here is we enter. This is our entry point. We're going to start running the code there. Okay, we start running there. First thing we're doing is we're prompting the user to enter a numeric grade. Okay, right, to enter a numeric grade. That grade is passed in. Okay, this is where we're actually calling the function. Okay. We're calling it there, right? We're passing that in. So effectively what happens here is when we call the function, what is really happening is effectively is numeric gets assigned the value of grade. Okay? We're passing that in. We're calling the function and we're setting numeric equal to grade. Okay? We then run the function logic, we return the letter grade, okay? And the end result of that is this whole thing here, right, becomes a type char, right? It's the output, and that is written here to that character, okay? Which we then print out. Okay. If I run this, right? I have this written here. Let me run it and show it to you in action. Right, I'm entering a grade. So I do 75 is a C. All right, if I run it again, okay, 92 is an A. Okay, we're not doing any range checking yet in this example. Okay, but keep in mind, one of the main benefits of this, right, is we've now kind of isolated that logic for how to convert a numeric grade to a letter grade. Okay, somebody who wants to do that functionality, all they have to do is call it. Okay, so if for some reason, if I wanted to do like for instance, if I wanted to convert multiple multiple numeric grades to letter grades, right? I don't need to copy and paste this code here or anything like that. I could just call it, right? So typically, as I mentioned in a previous video, that copy and pasting code is bad. It's a bad thing to do, okay? Because that's an indication that you want to move the code into, say, a function and then call the function, right? This way you have the code written in one place. If you need to change the logic, you change it in one location. You're not keeping track of code in multiple spots, okay? So like for instance here, if let me get rid of the prompts just as an example, right? If we wanted to do this with multiple letter grades, we could do something along these lines. Okay. Right, so I did it twice, right? Calling the function twice. And keep in mind, I don't need to have these on separate lines. Like, let me just kind of go back to doing it one time. Let me show you a couple. If I take this here, right, this becomes a character. This function becomes a character because it returns a character data type, right? So it's almost like, think about like the square root function. The end result of that is the square root, okay? The end result of this, get letter grade, is a letter grade, right? So I could even move that over here, okay? The end result of this is the letter grade of type char, right? That's going to work fine. I could go ahead and run that, right? It's going to say letter grade is C. Okay, letter grade is C, okay? Keep in mind what will, like if I go back, let me just back up a second, right? This will also print, right, letter grade is C. Let me just show you, right, so that works. This, however, will not work, right? I can't do something like this, okay? Let me just like initialize it to blank, okay? Notice here, this is calling the function, but it's not storing the result anywhere, okay? It's not storing the result anywhere. This is going to print letter grade is in blank space, okay? All right, I'm going to stop the video there so that we can follow up in other subsequent videos to go and look at more examples and go in a bit more detail of what is going on with how functions work. And look at, we'll also have videos that follow up looking at passing in arrays and do some more complicated things.